Hi, everyone. As he said, my name is Ivoline, and I'm excited to be here. This is my first time at SOUPS, so I'm excited but a bit nervous. So I'm excited to talk to you about our work on evaluating the usability of differential privacy tools with data practitioners. So our goal in this study was to understand the usability problems that data practitioners face when working with differential privacy tools, as well as find solutions to make these tools easier to use. To begin, let's step into the shoes of a data analyst. She wants to run queries on a data set that contains people's medical information. The analyst needs to learn useful information about the data without giving away anyone's private details. So this is where differential privacy comes in. Differential privacy provides a formal guarantee that the output of a query will not reveal too much information about any individual that's present in the data set. And this is achieved by adding carefully calibrated noise to the results of the analysis. So with differential privacy, the analyst can learn that smoking causes cancer without learning that John, who is in the data set, has cancer or not. But our data analyst quickly finds out that implementing differential privacy isn't easy. It is prone to error and complex. She needs to carefully manage the privacy budget, add the right amount of noise, protect against vulnerabilities, and much more. But luckily, several tools have been proposed to assist data practitioners, even without any DP expertise, to implement DP solutions. However, it is not clear that these tools help data practitioners like our analysts in effectively and easily implementing differential privacy. And if they don't, they might actually slow down the adoption of differential privacy in practice. So to address some of these problems, we performed a usability study with 3 key questions in mind. First, can differential privacy actually help data practitioners understand DP concepts? And can these tools help data practitioners implement DP solutions efficiently? And are data practitioners satisfied with the tools that are available for helping them keep their data private? So before we dive deeper into how we conducted our study, let's talk about the tools we picked. So we selected 4 tools for our study: OpenDP, PipelineDP, DiffPrivLib, and Tumult Analytics. So these tools stood out because they were open source, Python-based, they had a comprehensive documentation. They also had to be tools that aimed to be accessible to known experts and had the ability to support our usability testing task. So in the study, we first checked if people were eligible for a study through a survey. So people filling out the survey were required to answer Python and DP questions, among others, which helped us distinguish between DP experts and novices. So DP experts were people that answered at least 3 out of the 4 DP questions correctly. And at the end, we got 24 practitioners, 12 novices, and 12 experts. And each one of them was assigned to one of the 4 DP tools. So for each tool, we had 3 experts and 3 non-experts testing the tool. So here are the DP questions that were included in the eligibility and post-task surveys. We used the answers to these questions to categorize people into novices and experts, and also measure the improvement of DP understanding after the study. So once we had our participants, we conducted the study on Microsoft Teams. We began by providing everyone a handout that explained the basics of differential privacy. So the handout contained a short video introducing DP, and it also contained definitions and explanations of different aspects of differential privacy, like the privacy budget, sensitivity, composition, all that kind of stuff. We also gave them a tutorial that showed them step-by-step how to perform a simple count operation with the DP tool that they were assigned. Next, the participants got to work. So they used the tools to perform differentially private data analysis, and were encouraged to verbally express their thoughts during the task. So each participant was assigned 3 basic task to complete within 60 minutes. And this task basically involved performing the sum, the count, and the mean queries on a given synthetic data set. So after completing the task, we asked everyone to fill out a survey and take part in an interview. This gave us some information about their learning outcomes, experiences, the challenges they face, and how we could make improvements. So the post-task survey also contains the same DP questions that were in the eligibility survey, so we could compare the results. And here's what we found out. So for research question 1, the results showed that novices were able to improve their conceptual knowledge of DP after performing the task, but not so much for experts. So we see that the total number of correct responses from novices moved from 18 to 29. For research question 2, we wanted to understand how effectively participants could complete the task assigned to them using the different tools. So on the screen, we have 2 heat maps. The first one shows the overall completion rate for each of the 3 usability tasks and tools, and the second one shows the correctness rate. So interestingly, when it came to DiffPrivLib, every participant was able to complete all 3 tasks, but there was a significant issue in tasks 2 and 3, where all 6 participants violated differential privacy. So this was because most participants did not take sensitivity into account when running their queries. So they just used the default sensitivity of 1, which explains why they got the first answer correct, because the sensitivity of the count query is 1. There was one expert who thought hard about the sensitivity, but failed to use the right function in DiffPrivLib that enforces the sensitivity bounds by clipping. And similar mistakes were seen with PipelineDP, where DP was violated due to some mistakes, like simple errors, like a participant using strings instead of an integer to group keys in a histogram. And this produced unreasonable noisy results, like negative numbers, which was confusing to participants. Also, users of DiffPrivLib and PipelineDP were confused whether the tool tracks the privacy budget or not, so that was very confusing for users. On the other hand, the results for OpenDP were quite different. Most participants struggled to complete the task, with most people only completing the first task, task 1. However, when they did manage to complete the task, their solutions correctly enforced differential privacy. Tumult Analytics was the most consistent, where most users completed the task, and those who completed the task completed them correctly. We found that the variance in the completion rate was likely due to the differences in the API designs. So for example, DiffPrivLib has a simple API that works seamlessly with well-known data analytics libraries like Pandas. And similarly, Tumult Analytics is designed to mimic the Spark data analytics API. On the other hand, OpenDP doesn't make use of any popular libraries, which can make it harder for users. So this means OpenDP users had to understand technical details of differential privacy, like the composition of transformations, in order to perform their task. So participants preferred APIs that were similar to tools that they were already familiar with, and these results were also supported by participants' comments in the post-task interviews. In research question 3, we measure user satisfaction using the NPS and SUS scores, and you can see that DiffPrivLib had the best scores, followed by Tumult Analytics. They also align with the results from our qualitative results, which can be seen in the paper. And also, these results also align with the success rates associated with each tool, so which suggests that participants were most satisfied with the tools that made it easiest for them to complete the task. One thing to notice here is that a tool is considered to be good if it has an SUS score of 68 and above, and below 68 is poor. But the maximum SUS score here is 63, which shows that DP tools still have a long way to go. So in general, we found that there was a tension between preventing DP violations and maintaining usability. OpenDP's API was effective at preventing DP violations, but had lower completion rates and satisfaction scores, while DiffPrivLib's flexible API resulted in many violations and had high completion and satisfaction scores. PipelineDP was somewhere in the middle. Tumult Analytics seems to strike the best balance, as its API was effective at preventing DP violations, and users had high completion and satisfaction scores. So as you can see from the participant code on the screen, most people liked DiffPrivLib and Tumult Analytics because they were built with tools that they were familiar with. However, DiffPrivLib led to a lot of false positives because participants were happy after using it without knowing that they had violated differential privacy. So it's kind of like using an LLM like ChatGPT that gives you the wrong answer but with high confidence. So we recommend that tools should raise errors when DP is violated. Also, we saw earlier that OpenDP users were stuck in task 2 and task 3 and couldn't recover because of the error messages, because the error messages were in Rust, as you can see an example there. But most users were familiar with Python and not Rust, so making the error messages harder to understand and to debug. So clear and actionable error messages are encouraged. Most of the documentation was not searchable and appeared as one long page with no examples. This made implementing these basic tasks really frustrating. So we recommend having documentation that is easily searchable, has examples similar to other data science libraries, documentations that have examples of how to use most functions. And the documentation should also provide advice about what to do and not just how to do it. So in many cases, for example, participants had trouble deciding what mechanism to use. Like, should they use the Laplace mechanism, Gaussian, or geometric mechanism? It's not clear how to make that choice. Also, users were confused about how to set the privacy parameters, like the total privacy budget, the privacy budget per query, the upper bound, and so on. And this happened mostly with DiffPrivLib and PipelineDP, where most participants use the default values or struggle to understand what to set these values to. So yeah, here's a summary of recommendations from our study. There's also a link to our paper and study materials. Feel free to reach out to me if you have any questions, and thank you for listening to my talk.